G'day, Year 10. How are you going? Today we're continuing with our series on non-linear relationships. So that is relationships that lead to graphs that aren't straight lines. So last lesson we looked at parabolas, which are like a U shape. We looked at exponentials. And today we're going to be looking at circles. We're also going to be looking at how we can match equations and graphs together. Okay, so to be able to understand a circle, we need to understand both its equation and then what that looks like on a graph. Okay, so this is all about matching equations to their graph. Okay, we've got to be able to see those things as interchangeable, as two ways of expressing the same thing. So if we can notice key features in the equation, then we're going to be able to draw the key features in the graph. Okay, likewise, we'll be able to recognize the key features on the graph to then work out what the equation is. So for a circle, the equation or the general equation for a circle is what x squared plus y squared equals r squared, okay, where r equals the radius of the circle. Okay, so the center of this particular circle will be at 0, 0. Okay, and we're just going to be looking at circles that have a center at 0, 0. Basically, we're looking at, well, what is the radius of this circle? And then its center for what we're going to be looking at is always going to be in the origin, the middle of the graph. Okay. Now, for this question that we have here, find the radius of the circle with the equation x squared plus y squared equals 9. Okay, we know that r squared is going to equal 9. Okay, because the general form of a circle, that r squared value is the constant at the end, and we have that as 9. So then to find the radius, we just square root both sides. Okay, so the square root of 9, and it equals 3. Now, we don't have to do plus or minus because a radius is just a distance in any direction. So you could write plus or minus 3. It just means that, you're going to, the radius is going to be plus x and then plus y, but then also minus x and minus y as well. Okay, so this circle, then, if we draw a little point at, let's write the plus or minus in, just to be consistent. We're going to have a point where it passes through at 3, 0, 0, 3, and then minus 3, 0, and 0, minus 3. So all of these points lie on this circle. I'm going to try to draw my best circle, not my best circle. Okay, and so these points would be 3, 0, 0, 3, and then minus 3, 0, and then 0, minus 3. Okay, and you can see the radius clearly is 3 from the center, and we've just got a round circle there. Okay, so we've gone from this equation to this graph by just understanding the key features of the equation of a circle, identifying its radius, and then drawing the points and putting the circle in. Okay. Now, in this question, we've got to find the equation of a circle with a center at its origin and minus 5, 6 on its circumference. Okay, so what we're given is we're given an x value and a y value, but we don't know the r. So in the equation, x squared plus y squared equals r squared. Okay, we can substitute values for x. Okay, make sure you put brackets around the negative. Plus y squared equals r squared. And all we need to do then is solve this equation to be able to find what r is. So minus 5 squared is going to be 25. 6 squared is 36. Okay, that equals r squared. Add those together, you get 61 equals r squared. So therefore, r equals plus or minus the square root of 61. Okay, we just leave it at that. That's the exact form. We don't need decimal places. It doesn't specify, but that asked you to round to decimals, then you convert that to a decimal, but we can just leave it in the exact form as well, and that's fine. Okay, so we found the radius of this circle by substituting the values into the formula and then solving that equation by simplifying and then square rooting both sides to get r. Okay, lastly, what we need to be able to do is be able to compare the equations of different things and be able to match them with their different graphs. So we've looked at parabolas, exponentials, circles, and we've done previously straight lines. We need to be able to look at these equations here and be able to go, okay, which equation matches with which, okay? So the first thing that I notice is I have a parabola, 2 straight lines, and then an exponential, okay? I've got to recognize the difference between a parabola, which goes up on both sides or down on both sides. It's a U shape. An exponential is more like an L shape, okay? It could be like that as well, but it doesn't go up on both sides or down on both sides. So we've got to recognize the difference between the parabola and the exponential. So here's my parabola. And this is my exponential. And then I've got 2 lines. So one has a negative gradient and one has a positive gradient. So I can write neg grade, you know, just as some, and then pos. So those are the things that I've noticed about each of the shape of the graph. Okay, I've got a parabola, negative gradient, positive gradient, and exponential. Okay, now I've got to link them with each of the equations. Okay, so for this first one, I've got y equals 2 minus x. The coefficient of x is negative. So that's going to be a straight line because I've got just y and x. Okay, there's no x squared or anything like that. And I know there's a minus in front of the x, so it's going to be the negative gradient. So this one is going to be graph B. The next one is a straight line as well because it's y equals 2x, okay, just a y and an x, no squareds or anything. So that's going to have to be the positive gradient one, graph C. And then we have here x squared, which is a quadratic, and that forms a parabola. So that must be graph A. So as soon as you see x squared, but then it's just y, so it's not y squared as well, we know it's going to be a parabola. And then we've got y equals 2 to the x. So x is in the power. We know this is going to be an exponential. So this is graph D. Okay, so just a skill to be able to match different graphs with their equations by noticing the key features. So what shape is it going to be? Is it a negative gradient? Is it a positive gradient, etc.? Alrighty, good luck with the work today. I'll see you later.